Hi and Assalamualaikum. Today I will cover about this topic, which is fundamental theorem of calculus. As we know, this topic is really important in calculus. So before we proceed to the next, let us know what is the learning outcome that we will get from this topic. Okay, the learning outcome that we will get Now let us proceed to our learning today. So, what is fundamental theorem of calculus? As we know, fundamental theorem of calculus is an extremely powerful theorem that establishes a relationship between integration and differentiation. This theorem also gives us a simpler way to evaluate definite integrals without using Riemann sum or calculating the area under a curve. So this theorem has been founded and exploited by two mathematicians, which is Leibniz and Newton, during the late 16th and early 17th century. There are two parts in fundamental theorem of calculus. The first part is integrals and antiderivatives, and the part 2 is the evaluation theorem, which is we tend to use when we want to find the definite integral. So this is the theorem of the part 1, and this is the theorem for part 2. To more understand, we will go to the next slide. So, there is a connection between the fundamental theorem of calculus in part 1 and part 2. So, to illustrate that, let's say we have some function which is y equals to fd that is continuous between intervals c and d. And let's say the uppercase fx is the definite integral is equal to definite integral from between c and point x, which x is the interval between c and d. So in the first part on the fundamental theorem of calculus state that the derivative of uppercase fx is equals to lowercase fx. So the shaded region here is belong to the uppercase fx. And now for the second part of fundamental theorem, have state that fb minus fa. So to connect between these two theorems, let us say that we assume that fb is bigger than fa. So b is somewhere here and a is somewhere here. So the region for fb is right here, so we can denote it as the definite integral from c to b of the function fd, which is the green shaded. Okay, so for fa, we can denote it at this right here. So the definite integral will be like this. It is definite integral from c to a for a function fd. If we subtract these two function, we just get this region, the pitch region. So the pitch region we can denote that as the definite integral between point A to B of a function fd. So as we can see here, fb, function of fb minus fa is equals to the definite integral from point A to B for a function fd. That is because in the first part, that have been stated that the derivative of fx, the derivative of uppercase fx is equals to lowercase f, which in this case, the derivative of fx is here, and the lowercase fx is here. Okay, so we can see that f is antiderivative of f. So we can write it like this. Okay, so we just exchange the place. Okay, and this is the theorem of calculus for part 2, which we tend to use to evaluate the definite integral. So this theorem also we can write like this. Whether fb minus fa, we can write it like this, or like this, and also like this. So now let us proceed to the examples. So the first example states that evaluate the definite integral from -2 to 3 for the function x2 dx using fundamental theorem of calculus. So this is how we get that using the fundamental theorem. Okay, so the first step, we have to integrate the x2 into this. So as we know, when we integrate, we have to plus 1 the power and over the power that have been added with 1. Okay, like this. So we get like this, x cubic to the over 3, and then after we get the integration, we substitute the value of interval lower limit and the upper limit. So this is belong to the upper limit. So this is belong to upper limit, and this belong to lower limit. So after we substitute, we settle that, and we get those ones. And now let us proceed to the next examples. So for the next example, the question sounds like definite integral from 0 to 1 for the function 3x cubic plus exponent to the power of x. So the first step is we have to separate that function to be more easier. So like this, we separate that into 2 parts. Okay, and then we integrate. So after we integrate, we get that 3x to the power of 4 over 4, and exponent to the power of x. When we integrate, we get the same, exponent to the power of x. And then as I told before, we substitute the upper limit and the lower limit, and we subtract, and then we simplify the answer. So this is the answer. So welcome back, and this is the answer. So first we have to separate it, or we have to simplify the function into this, and then we have to separate it one by one, and then we integrate. So for x cubed, when we integrate, we get 4x to the power of 4 and 5, and then 5 we get 5x, and then for x negative 1, when we integrate, we get ln x, and then for 3x negative to the power of negative 2, when we integrate, we get 3x to the power of negative 1 over negative 1. So we simplify this, so 4 and 4, and then we can get like this. So after we get like this, we substitute the value of upper limit and the lower limit, and then we simplify the answer, and the final answer should be like this. And now we have come to the last section, which is the application of fundamental theorem in real life. So as we can see in this slide, there is many application of fundamental theorem in real life, but for today learning, I give you two examples. So first, we can use the fundamental theorem of calculus to calculate the free fall of paraqueties. Okay, so and the next is we can calculate using fundamental theorem of calculus for roller skating race. Now that's all from me. Thank you for watching this video, and I hope you learn something about fundamental theorem of calculus today. So bye and thank you.